Hey guys, in this video I wanted to show you how to read data from Neo4j database using cypher query language. The end goal of this video will be to generate some basic recommendations using the data we have. So I'm using here the recommendations database, which is provided by Neo4j Sandbox. If you watch my previous videos, I've showed it how to connect it. I'll leave a link in the description, but anyways, you can do it yourself. It's sandboxneo4j.com. You need to create new project and select recommendations, and then you can open it in a browser or connect to Neo4j desktop project. Right, so I've already did that, and here we have actually quite nice tutorial. So here they describe what are nodes, labels, and etc. The basics of the graph database, and then we have some recommendations actually. So we're gonna do this tutorial a bit later. I wanted to go through it and to dive deeper, but for now I just wanna go through bare bones and explain um, what is the graph database overall. All right, so let's get into it. So the first thing I want to do is to actually get the schema of the database. For that, we can use the following command. All right, and we are getting the schema. I'm going to zoom it a bit in here. All right, so here we have a visual representation of our graph database. As you can see here, we have circles and we have like arrows going to those circles. So the circles which we have here are called nodes, and these arrows are relations, and this is in a nutshell the graph database. It's represented by nodes and relations between them. So nodes describe the entities which we have in our database. You can think of them just as, say, JavaScript objects, and relations describe the connection between the source node and the target node. All right. So talking about nodes, they can have labels. As you can see, they have different colors and different uh, names here. So these are labels. A node can have one or multiple labels. Also, nodes, as I said, you can think of them as a JavaScript object, meaning they have properties which are just the key value pairs. And talking about relations, they, as I said, is a connection between two nodes. They always have a type, a single type, and they always must have a direction. So here we have a direction in this way. That's why this is a source node and this is a target. I think this is quite self-explanatory. As you can see, a single node can have multiple relations with the node. So we have 1 and 2. We can have as well relations go backwards into other direction, and as well we have the same time, for example, acted in relation can go this way and it can go other way. We can't have a relation which goes basically bidirectional. So if we want to have a relation which the same relations to the both sides, we'll need to create this relation twice and mention the direction we would like to have. All right, and the lasting relations like the nodes, they can have as well properties, and this as well key value pairs. So you can store them just like in an object. So this is probably, if you're coming from SQL, this is the main difference between SQL, that the relations here have a type and they can store key value pair, store some values basically. All right, I think this is it for now with the terminology. Let's write some queries and yeah, get the basic understanding of what we can get from the database. All right, so let's write a query which gets first 10 nodes from the database. All right, so to read the data from Neo4j database, the command is match, and then inside of the parentheses we need to specify the node we are matching. So here we actually mm, the first parameter which we specify here is just an alias, which we using for our returned values, and then we need to return some value. So we will specify the same node. And since this database is quite large, I'm going to add a limit of only first 10 nodes. So as you can see, it stands for itself. It's quite self-explanatory as well, limit 10. And let's see what we are getting from the database. All right, we got quite a lot of information. So as you can see, we got straight away nodes with the relations. and they have different colors, meaning we got different nodes. So as you can see here, it's a movie node, and here we got genre node. All right, this is because we didn't specify any labels when we were matching, and also we can get the key value pairs, basically the values we are getting from the database in the representation of the data. The first thing, we have the word node here. So this is the alias which we gave here. So if I'm going to change it to node 1, it's going to apply here as well. And then let's see what we are getting. So we requested first 10 results, and they are represented here. As you can see, 1, 2, 3, and so on. So we're getting the identity. So this is quite important because Neo4j assigns every node an ID automatically, internal ID, which we cannot assign by ourselves. It's once again assigned by Neo4j, and it's auto-incremented. So we get 0, 1, 2, and so on. Then we have labels here, movie. As I said, the node can have multiple labels. Then we have the properties, which are key value pairs, which are stored inside of the node, which is essentially our entity. They're described here as well, as you can see. All right. So what if we would like to get only some specific nodes? How can we start filtering data, right? So here we can add a column, and as you can see, we are getting the nodes. So what if I would like to get movies? I'm going to change node to movie as well, and let's run it. And now we're getting only movie nodes, all right? So this is the first 10 movie nodes. The same goes for any other node. We can specify it here. All right, and so essentially you can think of labels like movie is a way to filter out the data. All right, the other way we can filter out the data is using the properties we have on the nodes. So for example, we can use the title Sabrina, right? So we can specify it in here, inside of the curly braces. So it will be title, and we need to specify that it's a string, Sabrina, and we won't need to limit it out because probably there will be only one movie. Actually, there are two Sabrinas. Right, these are different movies. All right, this is a good example that we can also filter it out using other properties. So for example, we will use movie ID, and this will be 915. All right, and now we're getting only one Sabrina. And this brings me to the point that I'm using here 915 as a string. And how do I know that? Because in Neo4j, whenever you have a number, there will be a dot as well. So if it was an integer, for example, there will be a dot 0. So for example, IMDb rating is 7.7. So I know this is a number because obviously it's a decimal. So let's test it out. That IMDb rating should be 7.7, and let's see if I'm right. All right, yes, and we are getting the correct result. All right, the next thing is, what if we would like to filter out by a range of values? For example, if IMDb rating is larger than 5, or if we'd like to match a title which only contains a part of the string or starts with something. So we won't be able to do it here in line because here we are doing only the string comparison. So we're checking if title equals to this value. So for that, we would need to use a where command. And here we need to specify the node we're using. So it will be movie.title equals to Sabrina. Something like this. And let's check the results. And we're getting once again both of our movies. And if we would like to add another criteria, we need to add and command. And we can add another criteria. So here once again we specify the node. All right, and now we're getting only Sabrina with the IMDb rating of 7.7. And just in case here, you can use, for all these commands, you can use small letters as well. Doesn't matter, it will work as well. All right, now let's move to the interesting part. Let's add relations into the mix. So for that, let's take a look at our schema once again. So we were working with this movie node. Let me just zoom it out a bit. And now, for example, what if we want to get access to all the actors who played in a movie, right? So for that, let's use the same movie Sabrina. And to add a relation, we need to add a hyphen or a dash, and then we need to use a colon. And here we can see the relations which we have. So we will use the acted in, the relations which we have in here. Oh, sorry, in here. And now we need to add a colon once again. And here in the side of the parentheses, we need to specify what we are matching. So we are taking actor and with the label actor. Once again, this is just an alias and this is the label. And also we need to specify the direction. We specify direction not in the first column, but in the second. So here we're making direct relation from, actually, yeah, this might be a bit complex. So basically what I'm writing here is that we're going to start searching the movie and then we're going to look for the actor. So the relation actually goes from actor to movie. That's why I'm specifying it here. So we need to specify always the direction in the second part of the relation. Right? So in case if the relation was from movie to actor, this arrow would be here. And to add this arrow, basically what I'm pressing, I'm adding hyphen and then I'm selecting the large sign. And when I do it, it combines it into one symbol. All right, I hope it's clear. So I'm gonna add it once again and let's run it. And yeah, I'm returning only the movie. So let's add actor into return list as well. And now let's look at the result. We are getting both Sabrinas with all their actors. And once again, if you recall, I mentioned that a node can have multiple labels. So a movie node has only one label, right? Movie. But the actor has a person node as well. So we can change it to person in here. And we're getting the same results because all these nodes are the same. They share the same label person or actor, right? The next thing I would like to show you that we can filter it out by actor as well. So I can use actor. Let's return it back to actor because it's a bit confusing. So now I can use this alias to access the properties of the actor node. So for example, I can access the name and let's use this name, Humbert. Oh my God, what a name, Humphrey Bogart. All right, and now we are getting only these two nodes. The same goes for relations. We can use key value properties, key values, sorry, from the relations. So here we have role Linus Larabi. Hope I spelled it correctly. So let's add a label in here as well, sorry, alias. So we can name it whatever we would like, right? So once again, so here I'm getting actor and movie, right, in the results. So these are just labels. We can name them whatever we would like. So here I'm gonna add acted in, and let's remove the actor. I'm gonna add here acted in, and the property is role equals to Linus Larabi. All right, and oh, he played in both Sabrinas. Probably a remake. Nevertheless, I think you got the idea. And now let's actually start traversing our graph, meaning we're going to jump from one relation to another, from one node to another. So as you can see, here we have, for example, movie node, and we go to the actor. But what if we would like to get as well users involved? So for example, user rated some specific movie, and then we would like to get all the actors from the movies that this person rated, right? So let's write this query. Let me find some user. So for that, I'm going to write user and select the node user, and I'm going to return once again. Let me just type it out correctly. And I'm going to limit to 5 users. So let's use Jessica Sherman. So I'm just taking her name just as an example. So we have someone's name. So we have Jessica Sherman, and then now let's build out the relation. So from user, we will rate a movie. So once again, we do it like so, rate it. And now we will rate what? A movie. And another thing, we don't need to always specify the alias. We can, if we are not planning to return the value, we can just leave the label on the label here. But I'm gonna add it here. And let's return the movie for now. All right, so we see that Jessica rated Star Trek, another Star Trek. All right, lots of Star Trek ratings in the first 5 of those. And now we got this movie node. So for example, if I expand this node, you see that there is a lot of people who rated it as well. But here, as you can see, the blue one is the acted in. All right, maybe that's a bit confusing. So basically, this movie has its own relations. And now, since we got it in our return value, we can use it. So now I can build relations from the movie. And we know that movie, like we checked in the previous time, we have people who acted in it. And we can specify the direction here. And who acted in it is the actor. And now we have access to user, movie, and the actor. Let's add it in here and hope it's not going to be very messy. All right, let's increase the limit to 25. And now, ooh, look at this beautiful tree. Now we're getting some results. So we were able to traverse the graph from Jessica. As you can see, we jumped from Jessica to rated. So basically in here. And then from we were able to get the node movie right in here, and then from movie we moved to actor, but the relation is this way, so that's why, as you can see, relations goes here and now in here, and we are not using the arrow in the first parenthesis, in the first hyphen. We're using it on the second one, so here it goes backwards, right? Sorry if it's a bit confusing, but over time you probably will get used to it. I hope I'm making this clear. All right, so this is one of the biggest advantages of Neo4j database, that we are able to hop through the database and basically jump through relations. So yeah, when we are going from one node to another, this is called a hop. So we just made 2 hops, and let's see how fast it was. It was 6 milliseconds. All right, and look how beautiful this query is. It's kind of self-explanatory, and this is the, once again, a beauty of Neo4j. Even writing a query like this in SQL would be already quite complex. And here we can add any filters we would like. We can start filtering by rated, by acted in, and etc. All right, but now let's write a bit more complex queries. Actually, before that, one other thing I wanted to mention is that we don't need to always return the entire node, right? So we're getting the whole data in here. But what if I would like just to get the IMDb rating or just the title? So we can do it here by accessing just title, like so. Let's see what we are getting. Now we are getting from the movie only the title, and we are and yeah, basically we're getting the title, and as well we have the alias changed to movie.title in here, so I can change it to whatever I would like. So for example, I can name it title as well, and now we're getting just title in here. And as well, yeah, that's what I wanted to mention, that as you can see, we're getting the same title for over and over again, because we have numerous actors for the same title. And what if we would like to get the results only, for example, of all the movies the Jessica rated, and all the actors who played in those movies, but group those actors into one array. So for example, I want to get the actors' names and movie titles, and as you can see, we're getting the same movie. So for that, we can use a command named collect. Let me just make it bigger, and it will collect all the actor names and group them by movie title. So it will look something like this, and now we're getting a list, and now we can name it as list of actor names. All right, and looks pretty nice. All right, now let's finally do some basic recommendations. The first one, we will find the movie genre Jessica Sherman likes to watch the most. All right, let's look at our schema once again and understand what we are going to do. Let me close this one for now. So we got the user Jessica Sherman, right? And we're gonna jump to the movies she rated, and from the movie node we will jump to the genre, and then we will collect all the movies and find the which movie count is the highest, and based on that we will recommend her the genre. All right, let's write the query, and I hope it will get clear once I finish with that. So the beginning of the query will be the same, so I'm just gonna copy paste it. So we are taking Jessica Sherman and goes to all the movies she rated, right? And then from the movie node, all right, let's close this query. We will jump to everything that's in genre. So here in genre, and now we will move to genre node. So here we can get the colon, and sometimes I do it like so. And now let's return once again. We don't need actually the user. We can remove the user from here, just use the label. So we will return movie and the genre. And let's limit to 10 for now and see the results we're getting. All right. So as you can see, once again, she's a fan of Star Trek, apparently. So she's getting adventure, sci-fi, action, and mystery. All right. And all we need to do now is basically to group everything by genre. Let's check the property we have. So in the genre, we have name. So everything to group by genre's name and get the count of the movies. To do that, we can simply specify genre.name and it will group by genre's name. And here we will use command named count a movie, and we will name it as movie. Let's just mcount. All right, and here we will use as name. And let's see what we are getting. All right, so we're getting sci-fi 43, and this might be actually the wrong result because also we can add the ordering. So we will add order by count, and we will specify that it's descending. So DEC is descending and ASC for ascending. All right, and actually she likes the comedy the most, and then action, adventure, and so on. So as you can see, we can use already this query to recommend Jessica, for example, the most favorite movies she likes. I mean the genre, right? If she enters, and we can build some recommendations. All right, so let's move on to the next query. Okay, so the next query will be, let's find all movies which are similar by rating to a movie Snatch. So let's look at our schema once again. So I want to look at, for example, I know a user prefers to watch a movie Snatch and he rated it, for example, above 3, and I want to find all the movies which other users rated above 3 as well. So we will go from movie to users. Sorry, yeah, and from users to other movies which this user rated. Let me write the query and I hope it will make sense. So we will match a movie. As I mentioned here, we will use title Snatch, and from movie we will go to rated and get all the users who rated this movie, and here we'll add direction like so. Let's just see what we are getting for now. Sorry, movie and user. All right, quite a lot of users rated this movie, so let's just rate init rated, and let's see. Let me zoom it a bit and see what do we have on the property. So here, as you can see, we have rating on the relation, right? And so here we can access the init rating. Let's add a filter where init rated dot rating is above 3. All right, a lot of people rated it highly, above 4. All right, now it's way less. So let's find all the users who rated it about 4, 4.5, 4.5. All right, as you can see, we're getting the correct results. All the relations I'm looking in here, they have a rating of 4.5. Someone rated it 5. All right, so now we need to take all these users and find the movies they rated highly. So we're gonna jump from user once again to rated, and then we will take, I'm gonna name it recommended movie, something like this, and this will be a movie note as well, and this will be rec rating. All right, so here we will add another filter. So we want the rating which will go from this user. All right, let me show what I mean. So let's see how many notes this user, how many movies this user rated. As you can see, he rated quite a lot of movies, and we want to find the movies he, oh Jesus Christ. All right, sorry, actually I had to cut the video because my computer became very slow and my voice was cutting off. So yeah, let's continue from where we stopped. So I finished the query, and here, as you can see, I wrote where initially rated, this rating, the initial connection we made to user, and the recommendation rating, then to the movies all we found from this user, all above 4. So what we did, we found the movies with the title Snatch, it's in here, and then we moved to a user. For example, we found Emily Willis, and then from her we started to search for all the movies she found, right? And from the Snatch we also found this user and many, many more. And then we started to find for all the movies they have rated, and we are making sure that Emily rated Snatch above 4, and that all other movies in here, all these relations, they have rating above 4 as well. And now how can we build a recommendation? For example, we can group everything by the title of this movie, by rec.title, and we can get the count of ratings, right? So how many users rated this movie above 4? And this way we will get the popularity of the movie, for example. So to do so, we can use a command once again count, and we can just mention star, so it will count the number of the paths we built throughout this query, and we will just name it as popularity, something like that, and this we will name as title, and let's limit it to like 10, and once again let's order by popularity, so the most popular will be at the top, and let's run it, and here we go. We are getting the Fight Club Matrix Shawshank Redemption. All right, so this way we were able to recommend a movie to a person. So for example, if you going on some website with the movies and you watched Snatch before, this is how they can recommend you a movie, the other movie to watch for you, or they can add another filter by genre or something like that. And let me check some other things. So for example, if we Google for Snatch, right, and zoom it out a bit, look at what we are getting here. Actually, not Snatch. Let's Google Brad Pitt. And look what we are getting here. So for example, we are getting cast. So let's observe at this Google result, because I'm sure they're using graph database under the hood as well for all these search recommendations. For example, this one, people also search for, right? So what we have a note actor or whatever search result, and we got Brad Pitt, and then from Brad Pitt we have all the users who search for him, right? So different users like me, you, or whoever, and then we hop from their search results to from those users to whatever they searched, and this way we can build people also search for. So they are building this way recommendations what to show to you, and you see they're getting 1, 2, 3, 4, and view 5 more. So they're getting top 9 results of what people who search for Brad Pitt also search for. So yeah, I hope this makes sense. And I didn't overload your brain. I think, yeah, this will be it for this video. Thank you for watching. If you have any questions, please ask them. I'll try to explain maybe some topics in more detail. And in the next video, I will do the same queries, these recommendations in our Nest.js application, and we'll see how to write them using Cypher Query Builder. All right, once again, thanks. See you in the next one. Take care. Bye-bye.